Hello, my name is Ryan Speck, and today we'll be going over and conducting a correlation analysis. So for today's agenda, we will be going over a quick definition of what a correlation test is, 6 different correlation tests conducted using PSPP, takeaways from using PSPP, and of course any questions you might have. What is a correlation test? Correlation is a bivariate analysis that measures the strength of association between two variables and the direction of the relationship. In terms of the strength of the relationship, the value of the correlation coefficient varies between +1 and -1. The closer a relationship is to +1, the stronger the positive relationship is. The closer relationship to -1, the stronger the negative relationship is. The closer to 0 indicates potentially weak or no relationship. You will notice these examples in the current 6 tests I'm about to go over. So the first test here is between income and savings. So for the null hypothesis, there is no correlation between someone's income and someone's savings. And for the alternative, there is a correlation between someone's income and someone's savings. The correlation coefficient and the p-values were calculated using PSP, and we used a significant level below 0.5. A significant correlation emerged. As you can see in our R value, we had a 0.91, which was close to the +1, as I showed on the previous slide. This shows that there's a strong positive correlation between the two. Also, it gave us our p-value of 0.000, which meets the statistically significant level below 0.05. So in this case, the test is rejected and the null hypothesis and concluded that there was a correlation between someone's income and someone's savings. The second hypothesis test deals with income versus stock. The null hypothesis is there is no correlation between someone's income value and someone's stock value. The alternative hypothesis is that there is no correlation between someone's income value and someone's stock value. The correlation coefficient and its p-value were calculated using PSPP, also assuming that the statistically significant level being 0.5. In this case, a significant correlation emerged. Our R value still has a positive correlation, though it is much closer to 0. So in this case, we would have a weak to moderate correlation between the two. However, our p-value still meets below the 0.05 significant level. So in this case, the test rejected the null hypothesis and concluded that there was a correlation between someone's income value and someone's stock value. The third hypothesis test has to do with income versus wallet value. So there is no correlation for the null hypothesis between someone's income value and someone's wallet value, and for the alternative hypothesis, there is a correlation between someone's income value and someone's wallet value. So again, using PSP, we calculated the correlation coefficient and p-value, and then in this case, a significant correlation emerged. In this case, we have an R equals 1, which is a strong, perfect relationship between someone's income and someone's wallet. And we also meet the statistic significance level of p equals 0.00, which meets the 0.05. So in this case, the test rejected the null hypothesis and concluded that there was a correlation between someone's income and someone's wallet value. The fourth hypothesis test we did was savings versus stocks. The null hypothesis here is that there is no correlation between someone's savings values and someone's stock values. The alternative hypothesis is that there is a correlation between someone's savings values and someone's stock values. So the correlation coefficient and p-value were calculated using PSP, still assuming the significant level of 0.05. A significant correlation emerged. R equals 0.28 shows that there was a positive relationship while still weak to moderate. However, the p-value shows that we were statistically significant with a 0.00 meeting the 0.05 level. The test rejected the null hypothesis and concluded that there was a correlation between someone's savings values and someone's stock values. Our fifth test has to do with savings versus wallet value. So the null hypothesis here is that there is no correlation between someone's savings values and someone's wallet value. And then the alternative hypothesis here is that there is a correlation between someone's savings values and someone's wallet values. The correlation coefficient and its p-value were calculated using PSPP, still assuming the significant level of 0.05. A significant correlation emerged in this example as R equals 0.91, again showing a strong positive relationship as the value is closer to 1 and it's positive. And we were also statistically significant, as you can tell by the p-value being 0.00, which meets the statistic level of 0.05. So in this case, the test rejected the null hypothesis and concluded that there was a correlation between someone's income and someone's savings. The sixth hypothesis test, and the final one, is that there is no correlation between the stock's and value and the wallet value for the null hypothesis, and that there is a correlation between the stock's value and the wallet value for the alternative hypothesis. So the correlation coefficient and p-value were calculated using PSPP again, using the same significance level. A significant correlation emerged as R equals 0.19. While this is a positive relationship, it's still in the weak to moderate range as it's closer to 0 instead of 1. However, our p level still meets the significant level of 0.05 with a value of 0.017. So in this case, the test rejected the null hypothesis and concluded that there was a correlation between someone's stock value and someone's wallet value. So my takeaways from using PSP in this presentation is that PSPP is a great tool that allows you to do quick analysis of the data set. It also allows you to quickly summarize null and alternative hypotheses for quick decision making. It allows you to also do visual scatter plots, histograms, and etc. to show visuals better for understanding. It will also show from the correlation test you can determine a positive or negative relationship. Also from the correlation test you can determine if it's a weak or strong correlation. And finally, you can determine that if it's statistically significant based on the parameters you've set. Finally, I want to thank you for viewing this presentation, and if you have any questions, let me know. Thank you.